continuing to talk about limits and how they fail. We just finished up looking at one where you approach infinity on each side. Here we're looking at an example of a function of sine of 1 over x, where as you continue to get closer and closer to 0, your function oscillates up and down faster and faster yet. The closer you get to 0, the more it oscillates. So this is an oscillating behavior. There's no limit that exists. Yes, you know it's going to be between 1 and -1 because it's a sine of that. However, it still doesn't approach any one particular number between there. Now, the formal definition of a limit. Suppose that f is defined in an open interval containing c, but it may not have to be defined at x being c. We would say the number L is the limit of your function f of x as x approaches c, which is written this way right here, given the following criteria exists. Well, that for any number epsilon, and epsilon is on each side of your limit, and for each number delta on each side of your value of c, basically it's saying if you get arbitrarily close to your limit on each side of your function, which is epsilon units away, you need to be within delta units of c to get that to happen. Now there's a couple of ways that can be written symbolically. One of the ways is the absolute value of f of x minus L less than epsilon for all values of 0, 0 is less than the absolute value of x minus c is less than delta. You could also look at it this way here. I really prefer the bottom one. That says that if you are within delta units of c on each side, that means your function has to be within epsilon units of your limit on each side of that. Now, keep in mind that your limit does not actually have to be defined at that one particular point. That's really immaterial, what happens right there. What we do want to happen, though, is that on each side of that one particular point that you are getting close to that output limit. So this gives you more of an idea of what's going on with the limit. So let's go ahead and look at proving, using your delta epsilon, the limit as x approaches 3 of 13x minus 29 is 10. You should realize that, yes, it's going to be 10 because you could actually take 3, plug it in, you get 39 minus 29, and that is 10. Now, up above here lets you know what we're going to start out with. We're going to start out with your limit minus epsilon is smaller than your function is smaller than epsilon plus, or delta limit plus epsilon. So that's what we're going to start out with. Your limit here is your 10, so we're going to go 10 minus epsilon, less than your function, which is the 13x minus 29, less than your limit, which is 10 plus epsilon. Now we're going to solve it for x. And what we're hoping for is that we'll end up with, and we're looking for something like this here, where you are epsilon units on each side of your value of c, which is what x is approaching here. So we solve this, we go ahead and we add 29 to all three sides. And then we need to go ahead and divide everything by 13 to finish getting x by itself. And then you'll notice what we have here is really in this form, that you are on each side of 3. Since you ended up with a neighborhood on each side of 3, and that's what we were approaching for your limit as x approaches 3, whenever you are epsilon over 13 units on each side of 3, you're going to be within epsilon units of 10. So we started out with a neighborhood about 10, worked it down to get a neighborhood about 3, so that means your limit exists. And that's what we're saying here. Since we got a region around 3, a neighborhood on each side of 3, 10 has to be the correct limit. To maybe help you understand it better, let's go ahead and work with something where it's going to fail. When it's going to fail, you'll see what happens. Now, suppose we said the limit as x approaches 3 of our original function was not 10, but 23. So we still need to start out the same way, because at this point we don't know if that's accurate or not. We're going to go ahead and take our limit of 23 minus epsilon, less than your function, less than 23 plus epsilon. Once again, we're going to go ahead and we're going to solve it for x. So you're going to add 29 to each side. Then you're going to go ahead and divide everything by 13. And you'll notice we end up getting a neighborhood on each side of 4. We were really hoping for a neighborhood on each side of 3. Since we did not get a neighborhood on each side of 3 because we're 4 plus something and 4 minus something, we're a neighborhood on each side of 4. So since we're not a neighborhood on each side of 3, our limit is not 23. So since we didn't get that neighborhood around 3, we know we had the incorrect limit.